In this video, we'll discuss how Corona SDK handles dynamic image scaling to accommodate a variety of device resolutions. If you haven't already viewed the video on content area, please do so before proceeding, as the content area is closely related to handling images. Once you understand how to set up a basic config.lua file to scale your content area across different devices, the next thing you'll want to understand is how Corona SDK selects and displays images that are optimized for different device resolutions. For example, HD Retina devices versus standard devices. First, we need to discuss the cost and benefits of scaling images up and down. Remember that if you declare your content area as 800 by 1200, it scales across devices. Accordingly, when you place a basic image on the screen in Corona, it will be displayed in relation to the content area. For example, if you create an image that is 800 pixels wide, this image will span the entire width of the content area on all devices. In some cases, the image will be scaled down slightly, for example, on the iPhone 4. However, on high-resolution devices like the Retina iPad or Nexus 10, the image will be scaled up. Why is this important? As a basic rule, scaling a larger image down to a smaller size generally doesn't hurt the image quality, although it can, in some cases, result in jagged edges or other visual anomalies. Most concerning is when you attempt to scale a smaller image up to a larger size. In this case, the image will almost always become blurry, since the graphics engine must attempt to stretch the core image to a larger size. With this in mind, you may be tempted to simply create large images suited for HD Retina devices and let Corona scale them down for smaller screens. However, devices with lower resolution screens generally have less memory to display images. This can result in poor performance and even a program crash if you exceed the available memory on those devices. To cleanly adapt to multiple devices, Corona offers you a system where multiple versions of the same image can be included in your project. For example, a high-resolution version, a medium-resolution version, and a low-resolution version. Then, based on the device's screen size and the content area you set up, Corona will pick the best matched version automatically. While this entails more image files in your project and thus a larger compiled app, the benefit is that images will appear in the proper resolution on the device you're targeting and including images for. These days, most devices are either in the medium resolution class, 600 to 800 pixels wide, or the high resolution class, 1200 to 1600 pixels wide. For simplicity, we'll only deal with medium and high resolution screens in this video. Creating and naming the images. Let's start with a background image that is generic enough to work with many screen aspect ratios. For a sample content area of 800 by 1200 pixels, build a base background that is 960 by 1320. This image may be named as normal. For example, menuBackground.png. For high-resolution devices, create an image exactly twice the size, 1920 by 2640. In this case, append a suffix onto the same name you use for the base image. For example, menuBackground@2x.png. Remember this suffix and use it consistently for all double-sized images in this set. The suffix can be named however you wish, but it should be short and simple since you'll probably need to append this suffix to many images. The next step is to declare the image suffix options in the config.lua file. This is accomplished by including a separate image suffix table within the content table. Inside this table, declare at least one key value pair consisting of an image suffix and a scale factor. In this example, the image suffix of @2x is included, placed in quotes, and within brackets. As for the scale factor value, let's examine how 1.5 works in practice. The iPhone 4 has a screen width of 640 pixels. If we divide the iPhone 4 screen width, 640, by the content width that we declared in our Corona setup, 800, the result is 0.8. Since this value is less than the scale factor of 1.5, the non-suffixed base image set will be used on the iPhone 4. The iPad mini at 768 pixels in width also works out to less than 1.5, and thus the non-suffixed image will be used on these devices. When we look at high-resolution screens like the iPad 3 or 4, the second generation Google Nexus 7, or the Kindle Fire HD 9-inch, the calculations appropriately favor the suffixed at2x image set. Let's examine. 1536 divided by 800 is 1.92. That's for iPad 3 and 4. 1200 divided by 800 equals 1.5 for the Nexus 7 and Kindle Fire HD 9-inch. Notice how the latter two examples equal exactly 1.5, our defined scale factor for the at2x image set. This is acceptable as Corona will select an image set where the device scale factor is greater than or equal to the factor defined in the suffix declaration. One final important note on scaling. Although you can define as many image sets as you wish, there are simply too many screen sizes and aspect ratios to achieve a perfect 1-to-1 ratio on all of them. Therefore, you must accept some degree of scaling even when using dynamic image selection. In most cases, you should set up image suffixes that target devices of similar resolution. Then allow Corona to scale the images up or down slightly depending on the device. This minor degree of scaling will generally not be perceived by the end user since most modern devices have a very high pixel density. And that's a look at how Corona SDK handles dynamic image scaling to accommodate a variety of device resolutions. In the Displaying Images video, we'll look at how to load images onto the screen in Corona SDK. Learn more about working with Corona SDK at www.coronalabs.com/university.